In this demonstration, we're now going to look at creating and deploying our web apps to Azure. So we have our app service plan already created. Now we want to go ahead and deploy web applications into it. So let's start out first by deploying this from the portal. Okay, so in the Azure portal, let's select Create a Resource. Now that you have a good understanding of virtual machines, it's time to turn our attention to another one of the compute services, which is containers, which has grown a lot in recent years with the rise of Docker as a standard for a lot of the industry now. And what are containers? Well, essentially, it's a standardized packaging for software and dependencies. So think in a virtual machine, I typically have my operating system, I install my packages on, I install all my dependencies on, and I try to make sure that configuration works. With a container, I kind of pre-do all that work, make sure everything works together, and then when I want to run it, I just schedule it to run on a machine that's capable of running Docker containers. It's also a way to isolate apps from each other, and it works across both Linux and Windows servers, and allows separate apps to share the same OS kernel. Now, what's given the rise to this? And ultimately, it's application modernization, because there are a lot of issues with monolithic applications. If we install all our application code into a single server, minor code changes then require us to do full recompile and testing. The application becomes a single point of failure. Let's say one of those boxes there, the different colors you see on screen, one of those pieces goes wrong, well, potentially it takes down the entire system, and the application is difficult and often expensive to scale. So the answer to this is to break it apart into what we call microservices, where each service is its own individual application, if you will, and can be scaled separately. There's this concept of 12-factor applications. You make the app independently scalable, stateless, and highly available by design. And it helps to compare and contrast these, because when you think about monolithic, well, it's very simple to deploy. Inter-module refactoring, vertical scaling, technology monoculture are some of the themes we see there. When you look at microservices, it's all about partial deployments. Again, deploying the piece of the entire application that I need as needed. Strong module boundaries, horizontal scaling is the big difference. So with containers, and this is something to look out for on some of the exams, is if I want to scale out horizontally, containers are very, very good for that, because I can just scale out that particular service that I need to, as opposed to with monolithic, again, if typically, somebody comes and wants to scale the application, you just add in more CPU, add in more memory to the virtual machine to scale it. And the other big thing with microservices, it allows for a diverse set of technology, from a stack point of view. Let's then look at some of the keys to microservices. First of all, we have functional decomposition. As you can see by now, all those services tightly coupled together that are error-prone become individual services. That's the first part of everything. Then we look at horizontal scale. Scale what we need to, not what we don't. This could mean that for virtual machines, if we've got an application that's a mixture of services, we scale the virtual machines horizontally in a scale set. We could scale the containers. We could use serverless functions. We can kind of choose what we want to use there. In addition, now we can choose to decouple the data much more efficiently. I can pick the best database for the service. So if Service 1 would make better use of Oracle, we can do that. Service 2, Azure SQL. Service 3, Redis. Maybe Service 4, we've got Azure SQL there, but it could be like MongoDB or Cosmos or something like that. So you can really start to see the benefits that containers provide, in addition to just the speed and efficiency. When you deploy in a container, they deploy very, very quickly when compared to a virtual machine. They're up and running very quickly, and again, they're not as error prone because everything's been tested, all the dependencies are coupled together, so when we deploy the container, we're good to go. So to drill this home, let's look at containers versus virtual machines. Well, again, on the left, if you remember from the virtual machines module, we have our hardware on the bottom, our hypervisor, and then we deploy the operating system and application in each virtual machine. With Docker containers on the right, we still have our server, so that's our hardware. And now that could be running, say, VMware or Hyper-V, or it could be an Azure virtual machine before it gets to the operating system there. So again, the operating system here is like Windows or Linux. Then we run the Docker engine on top of that, but now we can just deploy our application. So you can see we're scaling and scheduling the applications. We don't have to keep scaling out that underlying operating system. That's not to say you don't have Docker nodes underneath that scale out to support the applications. That's obviously got to happen. We have to have enough CPU, memory, etc. to kind of make all the magic happen. But once you've kind of figured out how to manage that service, and things like Azure Kubernetes Service make that very easy, now you can focus on the application itself and scaling that out. It's time now to talk about one of my favorite topics, which is serverless computing, and a welcome addition to the Microsoft certifications. For one, what is serverless computing? Well, it's an answer to many people don't want to spend all their time managing infrastructure, managing servers, all those things. They want to spend their time building great applications. And serverless computing essentially allows us to do that. It's the abstraction of servers, infrastructure, and operating systems, and just takes that whole pain away completely for you. The way it works is it provides you with fully managed services, and you'll see the major three that Azure provides. You only pay for what you use, so it's very, very cost effective, very easy to scale as well, because you're only paying when you use those functions or those logic apps or the event grid, as you'll see coming up. And finally, it's the ability to stitch together applications and services seamlessly is what makes it so powerful. So just a great service in general. But something to keep in mind, there is a server running somewhere. Ultimately, you write the code, or you create the logic app, or you work with the event grid, but Microsoft has to execute that somewhere. It's going to take that service that you've written and run it on some compute somewhere. Now, there's three major computing services that you heard me kind of mention. Azure Functions, so these allow you to write different pieces of code in a lot of the common programming languages that get executed somewhere. Logic apps, which essentially are workflow engines, more of an orchestration type activity, more of a if this then that type option, if you've seen that on the internet. And then event grid is just kind of we have multiple triggers, multiple events going on. How do we react to these events and fire off the appropriate services in response? So all three of these work really well together. If we start with Azure Functions, though, a number of key features. For one, supports the following programming languages: C#, F#, JavaScript, and Java is now in preview, so you may not get asked that on the exam, but just so you know for the future. Pay-per-use pricing is a key feature of all serverless functions really, but in particular for Azure Functions is a great thing, and it can be used in two ways. One, as part of a consumption plan, or an app service plan. So an app service plan, as you'll learn about if you cover in app services, is where you can put web apps and other apps on the same compute infrastructure that you have a plan for. So you can combine your Azure Functions there. So instead of you going pay-per-use in the consumption plan, you can just use them as part of your app service plan itself, and more on that later on. It does have integrated security with major OAuth providers, Azure AD, Facebook, etc. And you can code in the portal or deploy via your standard DevOps tools. Now, logic apps, on the flip side, a little bit different. They're essentially a workflow engine. They used to orchestrate and stitch together functions and services just like regular orchestrations tools. If you've used ServiceNow Orchestrator or VMware Orchestrator, you'll probably be quite familiar with things like this, or even System Center Orchestrator if you've used that in the Windows world. It's the ability to visualize, design, build, automate. So think of that a little bit different. Azure Functions is all about taking our code, putting that together, maybe connecting it to other systems, making calls, etc. But we write the whole code out. Logic Apps is more about this visual orchestration engine that you have there, and supports a lot of different services, not just Microsoft services, as you'll see in the demos. In addition, there's some key constructs to understand. You have the concept of triggers and actions, and you'll see this throughout Event Grid as well. The concept is, we have a trigger, something that happens that we want to react to, and then that fires off the action. So think about this whenever you're doing logic apps. What do I care about that happens? And then, do I want to send an email? Do I want to send a REST call? Do I want to start a function? Do I want to connect to Dropbox or some other service out there? That's the general concept with logic apps. To end off this entire section on compute, let's just take a high-level approach and compare the three major compute options again. On the left-hand side, we can see we have virtual machines. So this is where we have physical hardware, a host operating system with a hypervisor controller running on top of that. On premises, that's typically VMware and Hyper-V. In Azure, Azure takes care of that for us, and we put our virtual machine on top of that. Our virtual machine has its own virtual hardware and can run, say, Windows or Linux, and then we deploy our applications inside there. When we look at containers, now again, we're sort of taking the physical hardware. We've got the operating system now, which could be Windows or Linux at this point, and a container engine running on top there instead. We no longer deploy the OS every single time we want to deploy a new application. We simply deploy the application along with its dependencies as containers which have already been tested and we know that they run effectively. Finally, we have serverless. So now we have physical hardware, host operating system, could be a hypervisor again, running some other additional application on top there to provide serverless capability, and that's the serverless runtime. And now we simply deploy functions and individual APIs basically that can scale out as needed. So instead of, say, taking that bit of code and packaging it in a container, this is a very small piece of code that can scale out. And typically, we don't like to see functions run any more than 10 minutes, which is the standard limit as of right now provided by Azure. So with all three of those, again, it comes down to decoupling. Containers is typically the sweet spot because it allows people to kind of package things up, do things in a little bit more familiar way, and get everything they need together. And then if you really want to get creative and you got logic apps, functions, and things that can scale on demand in a much more serverless way, then by all means continue down to serverless. Alright, so it's time for us to begin our journey down networking, and there's obviously a lot to cover here for the exam. If you look on screen, we've got this network overview image that Microsoft always presents us with, and you can see more on this at the link on the bottom of the screen. I do encourage you to check that out. There's just a ton of documentation Microsoft provides around networking. But if you look at the image on screen, on the left-hand side, we have our on-premises network with options for like an encrypted tunnel, direct connection, over to the right-hand side, which is our Azure network. And this right-hand side is where we're going to be focused on primarily as we work through this module. And there's all sorts of concepts there, but let's start with the VNet first of all. The VNet is one of the core pieces, and it has a number of capabilities that Microsoft provides for us to utilize with VNets in Azure. And if you look on screen, we've got a boundary there. So we've got our VNet boundary. Inside there, I've got two subnets, subnet A, subnet B, and I've got a couple of virtual machines in each one. Each virtual machine has a network interface card that connects it to the subnet, and then by default these subnets can route to each other because they're in the same VNet, and then if we want to, we can put an NSG, a network security group, which we'll hear more about later, around these to say, okay, I want to filter traffic between them. So this is kind of the core concept of just if I want to put machines out in Azure, VNets are the way to do it. So what are all those capabilities? Let's just kind of summarize them and work through this list. First of all, they are isolated. VNets are isolated from one another unless we choose to connect them to each other. So VNet isolation is very important, particularly in multi-tenant scenarios. They all provide internet access, so if we want to connect these VMs to the internet, we can do that by default unless we choose to restrict that, but that is available for us. They allow us to connect multiple Azure resources, not just virtual machines. We could put cloud services like web apps and other services in there. We can plug them into the same VNet as our virtual machines. Everybody can share that networking boundary if they wish. The VNet connectivity, I kind of mentioned briefly, again, we can chain these if we want to, so we can connect VNets to other ones, and there's various methods to go about doing that connectivity. We can provide on-premises connectivity, so we can allow VNets to route to on-premises, as you saw in that original diagram. We can apply traffic filters via network security groups. That's kind of the shields again that you can see on the screen there. And finally, VNets provide a number of capabilities around routing. So we have default routes available. We can also define user-defined routes. And so we can basically customize this to manipulate it in a way that meets the needs of our organization. If we look at some of the key points, let's just hammer these home. Number one, VNets are a primary building block for Azure networking. So just think of this as the core for everything that we do out in Azure and all the services we want to connect together. It's a private network in Azure based on an address space prefix, and this is something that we define. We create subnets in our VNet with our own IP ranges, so we need to plan for them. We do have to think about things like overlap in address space, much like we would on premises as well. We can choose to bring our own DNS or use Azure provided DNS, and there's more to come on that a little bit later on. And finally, we can choose to connect the network to on-premises or the internet if we wish to. But hopefully this gives you a brief overview. I think if you just understand these 5 points and work through the demos, I think you'll get a lot out of this and see very quickly how easy it is to connect all the pieces of Azure networking together. In this demonstration, we're now going to go about creating a virtual network and a subnet via the portal, and then we will follow that on by creating a series of subnets using PowerShell so we can do things much more quickly. But let's get started in the Azure portal. So to begin with, I've already created a new resource group called SL-Network, and on the left-hand side, I'm going to select Virtual Networks. And as you can see, no networks currently present. So let's go ahead and select Add. And the network blade comes up for creating a new virtual network. And let's give this one a name. So the first one we'll call SL-70.533-portal. Now we're not going to go too much into address spaces in this course. There's plenty of YouTube videos on subnet, and if you want to go about reading that, but for the purposes of this course, I'm going to create a /23 network for this one. So 10.0.0/23, and then I'm going to create two /24 subnets inside that /23. Next thing we need to do is go ahead and select our subscription. So I'm using my pay-as-you-go, choose our resource group. So we'll choose SL-Network, and you can see I'm doing this in North Central US. And now I need to name my subnet. So the first one, you can see it creates a default subnet. I'm going to call this subnet A. And we're going to give it the address range of 10.0.0/24. That's the first /24 inside of our /23 range. And we'll go ahead and click create. You can only create one subnet at this point from the portal. And within probably 30 seconds or so, our network will be created, but we'll speed things up here. And that's created, so we'll hit refresh. And there is our network. So now let's go inside there. And we can see if we scroll down to address space, we've got our 10.0.0/23, and let's go into subnets. And we can see we have subnet A, but let's go ahead and create subnet B. And you can see it's already picked the next /24 for us, so 10.0.10/24. And if you look closely underneath, it's saying our address range is 10.0.10 to 10.0.1.255. So we actually only have 251 usable addresses in there because 5 are reserved for Azure. And we're not going to cover network security groups and route tables yet. We'll come onto those later on. So go ahead and click OK. And that will create our second subnet. It should only take a couple of seconds. And we should have our subnet. So you can see we now have a VNet with two subnets, subnet A and subnet B. Alright, so we can do things via the portal, but it can get a little bit cumbersome, particularly when I want to create a lot of subnets. So for that, in this next example, I'm going to use PowerShell instead. And let's start off in Visual Studio Code, where I've already got a PowerShell script ready that I can walk you through. So the top section of the script is just declaring kind of the global pieces I need. So the resource group and the locations. In this case, I'm going to deploy this new virtual network along with its subnets that you'll see shortly into SL-Network, the same resource group I used before, and in the same location, North Central US. The second section, I've got my VNet name and address space. So I'm calling this one SL-7533-VNet-P shells to differentiate it from the portal one. And I'm increasing my address space this time. I'm going to use a /22 because inside of that /22, I'm actually going to create 3 /24s, and there wouldn't be enough space if I just stuck with the /23. Here, the next section, I declare in some variables around my subnets just so I don't have to type everything in with every line. So I've got subnet A name, which is SL-web, and that's the first /24, 10.0.0.0. Then I've got my next /24 for SL-app, which is 10.0.1.0, and then my next one for SL-data, which is 10.0.2.0. Next, I declare a variable which I'm going to use when I create the VNet itself, and I just called this $subnets. And in this one, I created a new Azure RM Virtual Network subnet config. And this takes subnet A's name and subnet A's address prefix and adds it there. So think of this like when I created that VNet in the portal, I associated a subnet with it. This is the first one. If I scroll further down, this is where I actually create my VNet and I include that subnet configuration. So I'm declaring this as a variable because I'm going to use it a little bit later, but the command here is new-Azure RM Virtual Network, followed by the name of the VNet, which again is SL-7533-VNet-P shell, which I stored further up, my resource group name, my location, and the address prefix for the VNet as a whole, and then the first subnet I want to create, which I reference with -subnet, $subnets being my variable for that. At this point, the network is created, but now I want to create those additional subnets. So I use these additional commands, which are add Azure RM virtual network subnet config. I reference the virtual network. I then reference my subnet configurations, which is my name, so subnet B name followed by subnet B's address prefix, and then I run that same command again for subnet C. Following that, I have to do one last task, which is to save the additional subnet configurations. They're only local at that point. They haven't been set against the virtual network, so I simply do a set Azure RM virtual network and specify the VNet, and then that will save the changes that we added when we added the additional subnets. So with all that, let's go over to PowerShell and run this. And I've got it here in my C drive script Skylines network folder, and I'm simply going to type in create. So create vnet.ps1 is the file I've got. Hit enter, and that is now going to go off and do all the hard work for us. So we'll give that about 20 seconds or so here. And that's completed, and then it's added the additional subnets, and now it's saved that config. So if we go over to the Azure portal now, go back into virtual networks and do a refresh, I now see I have this PowerShell version as well. So we'll select this one, and in there, if I go down to subnets, you will see that I have my web, app, and data subnets as well. So hopefully you can really see the flexibility and the ease of use that PowerShell will allow you here. I highly encourage you to get used to it straight away, and you almost certainly will get questions on the exam related to PowerShell commands in this area. Alright, so everything we've been talking about so far has been primarily focused around the Azure virtual networks and all the great software-defined networking services that we can build out there, but often we still want to connect that Azure network to our on-premises data center, and so we have a number of hybrid connectivity options available to us from Microsoft. First one, and very common, is site-to-site VPN. This is how a lot of people get going before they're ready to commit to something larger, and essentially this involves connecting your data center over a VPN device to Azure. The next one is ExpressRoute, which is kind of what people mature and gravitate towards as they adopt a lot of Azure and decide, okay, I'm ready for a dedicated circuit. Maybe I'm doing a large-scale migration. Maybe I've got a lot of data to access on premises and in the public cloud, and I've got apps running everywhere. I really want Azure to feel like a permanent extension of my data center, and ExpressRoute is a good method for that. And the third one is point-to-site, which is a very easy way to connect, say, your laptop directly into a virtual network. And we're going to cover all of these in a little bit more detail as we go through the module. So let's begin with site-to-site VPN, and you can see a couple of examples on screen right now, but let's just take a look at the top one first of all and focus on the basics of a site-to-site VPN. Well, on the one side we have our data center, in this case on premises. It's got its own IP range, and on the other side we have Azure with a VPN gateway. And essentially we just want to connect these two together. We have to have a public IP on the right hand side. You can see there we've got that VPN VIP, and on the right hand side we've got our VPN VIP there. And what we do then is we create an IPsec IKE S2S VPN tunnel between the two, and now they are connected. Now we can also do this across multiple sites, as I mentioned, so we could have multiple data centers with their own networks. Again, you can see in a lot of these examples we don't have any overlap in address space because that's obviously not going to work from a routing perspective, but multiple sites all connected in to the same VPN gateway. So there's a lot of flexibility there. If you've got a lot of offices or a lot of data centers that you want to connect in, you can do it that way. You could also create multiple VPN VIPs if you want to connect different offices into different VPN gateways and segments of Azure networks. So you can really start to carve this out in multiple ways. If we look at some of the specifics, you definitely need to know for the exam, a site-to-site VPN gateway connection is a connection over IPsec/IKE, that's IKE version 1 or version 2. It requires a VPN device in your enterprise data center that has a public IP address assigned to it. It cannot be located behind a NAT, and site-to-site connections can be used for cross-premises and hybrid configurations. If you definitely take one thing away, remember those 4 points for the exam. If we look at point-to-site, then in contrast, this is really about connecting clients directly into the network. So you can see on screen there we have a number of VPN client users, on the right hand side, and they could be a mixture of laptop, remote workers, could be people at their desks. But essentially, they've got a few options there. They can do an SSTP or IKE version 2 tunnel, as you see on the screen there, into the VPN gateway. Now, that's just like VPNing into your corporate network. When you want to access network resources in your corporate network, you might VPN in there. Well, same thing here. You're just VPNing into Azure, and now you have access to your resources in the Azure network. The one thing I will say about this, a lot of people use this in conjunction with, say, a jump box. You might VPN in, connect to a jump box, run it from there, or potentially look at some of the new services like Citrix and Microsoft's RDMI and things like that that'll coming out. There's a lot of ways to kind of solve these scenarios. And I'll bring that up because there's a few things you definitely need to know, especially for the exam here. Obviously, we understand it's a secure connection from an individual computer, and it's great for remote worker situations. There's no need for a VPN device or public IP. We can connect wherever we have an internet connection. OS support is something we have to consider, so it's all Windows support primarily at the moment. Throughput and scale is the big thing, though, that we have to be concerned about. Throughput's up to 100 megabits per second, and this is unpredictable due to the internet, and it just doesn't scale easily. This is difficult to manage. It's really only useful for a few workstations that you might want to connect in this manner. Now, in addition, you also need to know about the different VPN gateway SKUs that are available to you. So if you look at the bottom there, starting with the basic SKU, it has a maximum of 10 tunnels available. For the point-to-site connections, it's 128 across all of the SKUs. But the other big difference, if you look at the basic one, it really has a maximum throughput of 100 megabits a second, so that's not very much. You really have to get into VPN gateway 1, 2, or 3. Where they start at 650 meg, going up to 1 gigabits a second on VPN Gateway 2, 1.25 on VPN Gateway 3, and those gateways allow for the max of 30 tunnels, so a lot more flexibility. If you look at it from a recommendation standpoint, pretty much if it's a production critical workload, you're not going to use the basic. You're just going to pick the VPN Gateway SKU that meets your throughput requirements. If it's dev test or proof of concept, then sure, the basic SKU is fine. And then at the bottom there, you can also see we've got the SKU, whether it's basic or the VPN gateways, and just the features on the right hand side. So if you see a few things there on the basic SKU, policy-based VPN does not support point-to-site. Already mentioned it's kind of 10 tunnels maximum. When we're looking at route-based VPN, the policy-based is only 1 tunnel. And then if we look at the VPN gateway SKUs, again, up to 30 tunnels, point-to-site, BGP is supported, so that's the Border Gateway Protocol for routing. And you've also got custom IPsec, IKE policies, express route VPN can coexist. So we could have like an express route connection with a VPN failover as well. So that's kind of just a summary of your gateway recommendations there. Now, if we want something a little bit more dedicated, a little bit more private, better guaranteed throughput, we can move up to something like ExpressRoute. And this essentially is a dedicated circuit between us and Microsoft Azure, and it works in a number of steps. So first of all, we have our network on the left-hand side. We're going to choose a partner to work with who's going to provide that connection all the way across to the Microsoft Edge. And then we have the flexibility of looking at the private services or the public services available to us in Azure. And that's really important. If we look at the private services, this allows us to connect directly to anything we've created like VNets, etc. in Azure. The public services, in contrast, this is things like Office 365, as well as services like blob storage, PAS SQL services, Power BI, etc. These are kind of those services that are publicly exposed in a public address space, and we can choose to have those connected to our circuit, if we want to or not. Now, in addition, you've got some connectivity models that you need to choose between. There's 3 major ones available. One, very common now, is a lot of people have started to use these cloud exchanges in a colo location. That could be like an Equinix facility as an example, and they will provide the cloud exchange for you and connect you into Microsoft Azure. We could do a dedicated point-to-point Ethernet connection that could be set up with our partner, and they would help facilitate that. Or we could do something like an any-to-any IP VPN connection over a MPLS WAN type scenario. If we look at the key benefits of ExpressRoute, and there are definitely many here, but let's just hit on some of the main ones. Well, first of all, this is now providing layer 3 connectivity between our on-premises network and Microsoft Azure's network. So it adds a lot of flexibility in allowing us to share resources between the two data centers. It allows connectivity in all regions, so to every Microsoft Cloud service across all regions in the geopolitical region. But in addition, you can add on ExpressRoute Premium add-on, and this allows to Microsoft services across all regions with that add-on, so global connectivity at that point. In addition, we've got dynamic routing, so this uses BGP, so this is the industry standard protocol. So between our network and Microsoft, we have that all built in, and there's built-in redundancy. So in every peering location, Microsoft is ensuring redundancy of hardware at every single point along the way, so we don't need to worry about that in addition. Okay, so you've decided you want to move up to ExpressRoute, but what does it take to get all of this provisioned? Well, there is a bit of a process, and it can take many months sometimes for this to be completed. This isn't as simple as just going into Azure and clicking new service and it's up and running. There's data center work that has to be done. And so there is a workflow. Let's just kind of walk through that. First of all, ensure your prerequisites are met. So you need to have a connectivity provider identified and set up a business relationship with them. Make sure you have your Azure subscription, and you have to set up physical connectivity with your provider as well. Then you go about ordering your ExpressRoute circuit. You're going to select things like your peering location, your bandwidth, your billing model, and whether or not using the standard or the premium SKU. Next, the service provider is going to provision that connectivity. You're going to provide them with some information. There's a service key you have to give them. They're going to provide you with information and get that connected. You'll work together to establish that connection. And then you can start using your ExpressRoute circuit, and you can link your VNets to Azure private peering. You can link to public peering. All of that suddenly becomes available to you. Now, in addition, it's worth noting some of the data that you have to collect. And some things here are very, very important, because for private peering, public peering, and Microsoft peering, you're going to have to create some /30 subnets for your path. So for path 1 is a /30, and for path 2 is a /30. That's for private peering. For public peering, it's the same, but you must have a public IP, and same for Microsoft peering as well. So these are pieces of information you have to have on hand in order to be able to establish that circuit. And now it's very important just to know about the /30. Often in the exam, you'll get some questions around space and subnetting, and just knowing around, that those require /30s is very, very important. If we kind of look at one other aspect of this, there's the concept of unlimited versus metered. So if we look at unlimited, first of all, speeds from 50 megabits a second to 10 gigabits a second. You have unlimited inbound data transfer, unlimited outbound data transfer, but you do pay a higher monthly fee for this unlimited option. Now, naturally, if you look at the metered option, well, you still got the same speeds, so you can go from 50 to 10 gigabits a second. You've still got unlimited inbound data transfer, but the big difference is the outbound data transfer is charged at a predetermined rate for gigabyte. Now, there's a lower monthly fee for that, obviously, because you're sacrificing that outbound unlimited data transfer. And, obviously there, if you're bringing data in and you're just moving into Azure, metered may be the way to go. But if you foresee a lot of traffic going both ways and just watch for questions on this, then, the unlimited option would be better for you. So to end off, let's just take a look at some of the ExpressRoute considerations. There's 3 major areas. One, just understand the model. So the difference between unlimited data and metered data. If you're trying to do this in your own data center, understand what model you're using today to accelerate adoption, understand the differences in port speeds, locations, and approach, things like that. Understand the providers and what they offer. And finally, understand the costs. If you think of these 3 things, models, providers, costs, you'll be well on your way to being able to answer any of the ExpressRoute questions they might throw at you. And with that, this ends this module. Hopefully this gives you a good background on everything you need to know from a connectivity standpoint. Like I said in the exam, the questions will be focused around you picking probably the right SKUs around the VPN gateway, so definitely know those. Choosing between ExpressRoute connection versus site to site, when to use point to site, things like that are likely to come up. And with that, that's the end. Thank you. Let's now take a look at the Azure load balancing services you're expected to know about for the exam. And first of all, we have Azure Load Balancer. This is the most common one. This works at the transport layer, so think layer 4 in the OSI network reference stack. It provides network-level distribution of traffic across instances of an application running in the same Azure data center. Now, in contrast to load balancer, we have application gateway. This works at layer 7, the application layer. It also acts as a reverse proxy service, terminating the client connection and forwarding requests to back-end endpoints. And finally, we have traffic manager. Think global scale, globally distributed endpoints. This works at the DNS level, so we might have applications running in multiple regions and users coming in from multiple locations. That's where we would utilize traffic manager. Now, in more detail, let's look at Azure Load Balancer first of all. So as I mentioned, it's layer 4. It's important to know that there's basic and standard SKUs now available. Now, the standard SKUs are in preview. They're not required for the exam, so you're only expected to know about the basic one, but just know that's coming out, and we'll certainly update the material when that actually happens. You have something called service monitoring as a feature. This allows Azure Load Balancer to probe the health of various server instances behind the load balancer. When a probe fails to respond, the load balancer can stop sending new connections to the unhealthy, let's say, virtual machines that are behind the load balancer. We have something called automatic reconfiguration as well. So this can reconfigure itself automatically when you scale instances up or down, perhaps when you add new web server instances as an example. Next, we have something called hash-based distribution, and this is how Azure Load Balancer distributes its traffic. And by default, it uses a 5-tuple hash composed of a source IP, a source port, destination IP and destination port, and protocol type to map traffic to the available servers. It also provides stickiness only within a transport session. So this means that if a client comes back, has the same session, they will continue to connect to their same, say, web server behind the load balancer as well. And finally, there's internal and public options, and you'll see some of the examples in a minute, but just know you can configure an internal load balancer for traffic to hit it and then disperse for internal applications, or it could be people coming over the internet and you want to expose a public IP, and then once they hit that load balancer, then we pass traffic to the servers behind the load balancer. So let's look at some of those examples. First of all, look at an internal example, and in this case we have our internal load balancer at the top there, which has a private IP associated with it that can be dynamic or static as well. You can decide how you configure that. And then we could have, say, 2 database servers behind the load balancer. Traffic will hit the private IP and then be sent over to one of either DB1 or DB2. Now let's look at a public example where if we look at the load balancer, which is in the center of the screen, traffic would come through the cloud at the top there over TCP port 80, and then we would pass the traffic down to one of the 3 available web servers that are behind the load balancer there. Now you're also going to get multi-tier examples as well. So in this case, you might see traffic come in and hit one of the 2 load balancers. First of all, traffic from the public cloud would come in and hit that web load balancer at the top, and then that would pass the traffic down to the web tier. Now those virtual machines that are perhaps the websites would then pass traffic to another load balancer when they want to query the database. So in this case, the second load balancer there goes in front of the database servers, and the web servers just query the database server. Now it's also possible then that people internal could just hit that database server if they wanted to from other applications as well. Could be coming from the website. It opens up a host of options for you there. So let's shift our attention now to the App Gateway, the other load balancer that's available to us from Azure. And first of all, it's layer 7 app load balancing, as I mentioned before. So just keep that in mind the whole time. When we want application load balancing, we need App Gateway. When we want just layer 4 load balancing, we can get away with just Azure Load Balancer. But a couple of unique features as well are important. So cookie-based session affinity, this is a common requirement for many web applications, and this is required so that a user can maintain the same user session on a back-end server. It also supports SSL offload, so all those decryption tasks, etc., that web servers would normally have to deal with, they don't have to deal with that now. They can offload that to App Gateway, and it can take care of it for them. We also have end-to-end SSL, so App Gateway supports end-to-end encryption of traffic. It does this by terminating the SSL connection at the App Gateway, and then applies routing rules to all of the traffic, and then it re-encrypts the packet and forwards it to the appropriate backend based on the routing rules that you've defined. In addition, one of the most popular new features that they added recently was around web application firewall, and this has become a key feature. When you enable this, it provides protection for web applications from a lot of common web vulnerabilities and exploits. This can include like SQL injection, cross-site scripting, things like that. And you also have URL-based content routing, and this allows us for directing traffic to different backend servers based on the content that the user is actually requesting. Different server can serve that content up. And finally, one very important thing is App Gateway does require its own subnet, and you need to create that subnet before you can create your App Gateway, and you'll see this in the upcoming demonstration. In addition, there's a few things you need to know around App Gateway sizes. In the following table, this shows you an average performance throughput for each application gateway instance, and this is shown with SSL offload enabled. And Microsoft does make a caveat on their website for this. These values are approximate values for an application gateway throughput. The actual throughput depends on various environment details, such as your page size, the location of the backend instances, and the processing time to serve up a page. So just keep that in mind as well. Finally, if we just take a look at a comparison overall, we've covered Azure Load Balancer, we've covered App Gateway, and we've covered Traffic Manager just very briefly there. So just think at the top level, technology, what am I trying to do? So if I need layer 4, Azure Load Balancer, if I need layer 7, App Gateway, and if it's something more geographically dispersed, think DNS level, think Traffic Manager in that context. As far as endpoint monitoring, it's worth noting at the bottom, it's all supported via probes for Azure Load Balancer and Application Gateway, but Traffic Manager is supported via HTTP and HTTPS GET requests. As far as endpoints go, that's the other different feature there. Azure Load Balancer supports Azure VMs and Cloud Services role instances. Application Gateway supports any Azure internal IP address, public internet IP address, Azure VM, or Azure Cloud Service. And Traffic Manager supports Azure VMs, Cloud Services again, Azure Web Apps, and external endpoints as well. So that's just a brief summary there of all the different load balancing technologies for you. But that's it for this tutorial section. I encourage you to check out the subsequent demos. In this demonstration, we are now going to go about configuring a load balancer in Azure. So let's head straight over to the Azure portal. Okay, and in the Azure portal, just to set the stage for everything, if we go over to virtual machines, you'll notice that I have 3 virtual machines for this demonstration. I've got a jump box that I can RDP into over a public IP address. I've got 2 virtual machines, SL Test VM 01 and SL Test VM 02. Both of those VMs are running a simple IIS website. So if I just go into, say, Test VM 02, and I'll connect in there. And if I open it up and just type in HTTP localhost, you'll see that I'm on Skyline's VM02. So on each VM, I've just got a basic web page that's been served up and just identifies the virtual machine. So we'll go back to the Azure portal, and let's now go ahead and create our load balancer. So let's go to Create a Resource, select Networking, select Load Balancer, and we first have to go about creating the front end portion of the load balancer. So in my case, I'm going to call this SL-internal, because we're going to create an internal load balancer -LB, and I can select here between public and internal. So we're going to choose internal, but let me just go back and show you public for the moment. When I choose public, I can choose a public IP address. This could be one I've already got created, and it can't obviously be associated with another machine already or another load balancer already. And if I want to, I can just go in here and create a new public IP, much like I would anytime I created a public IP address. But I'm going to do this internal for the moment, so let's hit internal. And when I do it as internal, I get a choice of the network, so I'm going to choose my VNet, and I'm going to choose my subnet. In this case, I'm going to choose subnet A. And you can see then I can choose how the IP address is assigned. So I can choose to statically assign the IP and just type it in this box, or I can choose dynamic and Azure will assign one to the load balancer. Then I've got my subscription and my resource group, much like every other service we create. So I'm going to use SL-network for my resource group, and I'm deploying this in North Central. So that's the front end portion of the load balancer. And if I hit create, and we'll fast forward while that creates, should take just under a minute for it to complete. And that's completed, so we'll go to that resource. And now I can start the back-end portion of the load balancer. So you can see the configuration screen. On the left-hand side, if I select front-end IP configuration, you'll see the IP that's been allocated 10.0.0.7. That's because we made it dynamic. But now I can start configuring these three things underneath: the back-end pools, health probes, and the load balancing rules. And I'll do them in that order. So we'll start with back-end pools. And the first thing we need to do is click Add, and give it a name. So we'll just call this SL Web Backend. And now I choose how I want to associate this. So I can select this drop down, and I can associate it with a single virtual machine or a virtual machine scale set, or in my case I'm going to choose an availability set that I already have. Select that drop down, we'll select the SLAS-web, that's my availability set with my 2 web servers running in it. Select that, and now this is very important, you need to add your target network IP configuration. So you're going to need to do 2 of these, one for each virtual machine. So we'll select this box, scroll down, choose our target virtual machines. I'll do number 1 first of all. And we can see it's got 1 network interface. And if you hit this drop down, select the IP, and then we'll select Add again. And now we will do number 2. Select its IP, and go ahead and select OK, and that will now create that backend pool. Just hit refresh. You can see SL Web Backend already there. It's still actually provisioning, so it's got 1 virtual machine in there now. Refresh again, and there you can see we have 2 virtual machines. If I expand it out, both of those are running and are in the backend pool. The next thing we need to do now is add our health probes, which essentially monitor the virtual machines and check they're healthy and available. So let's go over to health probes, select Add, give it a name, and then choose the protocol that you wish to check for. So in my case, I'm actually going to just select HTTP, and then I could select port 80, give it a path, but these paths are really important at the bottom. The interval is the amount of time between probe attempts in seconds. So every 5 seconds it's going to check health status. And unhealthy threshold, this is the number of failures that have to occur before it considers the VM behind the load balancer unhealthy and will then take it out of the pool. And that's all there is to the probe. Go ahead and click OK. Take about 30 seconds or so. Wait for this to update before you go on to the next piece. Okay, and as you can see, our probe is now there. It's still updating, so we'll just give that a few more seconds. There we go. And now we go over to load balancing rules. So in load balancing rules, this is where it all comes together. Select Add, and now we give it a name. So I'll just call this SLLB rule. And I can choose my IPv version, so 4 or 6. In this case, we're using version 4. But now I select my front-end IP address. In this case, I choose that one I created previously, 10.0.0.7. I choose my protocol, so in my case I'm going to use port 80, and then I choose my backend port followed by my backend pool. So in this case I'm using that backend pool that I created, SL Web Backend. If I expand that out, you can see that's the only one I've got there, followed by my health probe, which is for port 80, HTTP. Now if we scroll down, there's a few more settings. For example, session persistence. This allows me to maintain session state based on either the client IP or the client IP combined with the protocol. In addition, I have my idle timeout, and finally floating IP. This is really for SQL always on availability groups that you would use this. But if I go ahead and select OK, this is now going to update the load balancer configuration. So again, we'll fast forward here. It'll probably take about a minute. Okay, and we can see that that load balancing rule was created successfully. Let's go back to the overview and just grab our IP address, in this case 10.0.0.7, and let's head over to our jump box machine to test it out. And so I'm just going to fast forward here as I RDP into the jump box. It's a VM in the exact same subnet as our test VMs. So we're now in the jump box itself, and let's open up a web browser. And if we type in 10.0.0.7, and you can see I got Skyline's VM01 returned. Let me refresh again. Didn't get anything different there. Let's try an incognito window. We'll do 10.0.0.7 again. And you can see I did a refresh there. Now I got Skyline's VM02, so it's put me on the second server. And that is all there is to it. Both of those VMs are now successfully in an availability set that we created previously when we built the VMs, so they're highly available across 2 fault domains, and they are successfully behind a load balancer as well, so traffic is being dispersed between both of them. And with that, this concludes this demonstration. Alright, in this section we're now going to have a look at CDN, also known as Content Delivery Network. And it helps to think about how users interact with content around the web so we can understand how the CDN fits in. So to begin with, let's think about it as if we have a source of data. Maybe this is like a web application and people are going to a website and retrieving a bunch of images. Typically, in the case of our user here, Theodore, he would go ahead and make the request to the source, the origin, and the origin would serve up the content. Now the problem here is that if people are across the globe, let's say we have people in the UK, Australia, South Africa, etc., we don't necessarily want them always coming back to the US to get their images and various pieces of content. So the answer to that is to use a CDN. And what we do is we put in an edge in between the source and the user. So Theodore, for example, the first time he goes to access the content, we'll try to retrieve it from the CDN. Now the CDN doesn't have the content yet, so the edge will go ahead to the source, grab the content, cache it in the edge, and then serve it up to Theodore. Now his current experience, if he was in, say, one of those regions across the globe, wouldn't be any better at this point. However, the next set of users that go ahead and request the content, they go to the edge, request the content, and it's served up directly from the edge. So there's multiple points of presence across the globe where this content is cached and is available to users across the globe, so they get a much better latency response time when they're serving up the content. Now in Azure you have 3 major offerings that you can utilize in order to take advantage of CDN. There's standard Akamai, and I'll get into some of the features of these in a moment. There's standard Verizon, and there's premium Verizon as well. And it does help to go ahead and check out this link here, because there's a huge table just of all the different features available in each of them, and we'll sort of head over there in a second and kind of cover some of them. At a high level though, when you look at the offerings in the portal, you'll notice a few things that really kind of stand out as differentiating between the different services. In particular, if we look at Akamai versus Verizon, what you'll notice in Akamai is they put a lot of emphasis on this media optimization. So let's go ahead actually and switch over to the website and take a look at the table there. And here we are. As you can see on the web page, if you scroll down to the features section, you'll see this here. It specifically mentions dynamic site acceleration, adaptive image compression, dynamic site acceleration, object prefetch. Those are features that are only available in standard Akamai. And so you may be wondering what those are. So if we look at dynamic site acceleration, adaptive image compression, think of this like, most websites consist of an HTML page, which, you load it, and then it goes out and requests all of the images. So what prefetch does is it actually, retrieves the images of scripts embedded in the HTML page while the HTML is served from the browser, even before the browser requests the object. So think of it like you may go to your favorite web page and you sign on, but immediately it's already grabbing the images while the HTML is still rendering in your page. And then the other big one here, around adaptive image compression, some devices, if you think about it, especially mobile ones, experience like slower network speeds from time to time. I know this happens to me all the time when I'm on the train, on the way to Chicago, and the network speeds kind of come and go. And in these scenarios, it's beneficial for the user to receive smaller images more quickly rather than waiting for the full resolution images to come down. So this is a great feature. If you go to a web page that supports this via a CDN, rather than you sitting there waiting for the images to load up, it's going to serve up smaller versions of those. Now they may not look, they're not going to be as high quality, but you'll get them more frequently. The other big one is, around video. The request patterns of streaming have a lot of challenges. When you think of a popular live stream of a new series or a new video on demand that gets released, thousands and thousands of viewers might request to stream at the same time. And in this case, you need some smart, technology to really deal with that. And so the technology from Akamai, has a feature that delivers streaming media assets efficiently to users across the globe at scale. And this reduces latencies because it reduces the load on the origin servers. So if you think about your origin server having to kind of deal with all of this, you don't have to worry about that because that's offloaded to the Akamai engine that's basically taking care of that for you. If we shift down to some of the features that are kind of unique to Verizon, if you scroll right down to the bottom, one in particular, aside from some of the management and ease of use things, is this ability to use a rules engine, URL redirect, rewrite mobile device rules. This is something that's unique to the Verizon offering as well, and this allows you to customize how HTTP requests are handled. So for example, you can block certain types of content, define your own caching policy, modify HTTP headers. Those are things that are unique to the Verizon premium offering in particular. So when you look at these, and we'll go through in the demonstration how to kind of create a CDN endpoint in a moment, but just as you look at these, the two things to stand out for the exam are, okay, if it's optimized for media, I probably should be looking at the Akamai engine. And if I need something more around rules and redirection and blocking content, etc., Verizon just has a lot more features in that area. In this demonstration, we're now going to go about configuring a CDN and demonstrating that by the use of images that we'll store in Australia. So let's go ahead over to the Azure portal. And to begin with, you can see that I've already created a storage account called SLCDN Demo AUS for Australia. And if I go into that storage account, go into blobs, you'll see I've created a container already there for images called CDN images. Expand that out, and you can see I have a whole bunch of images in there, and they're stored in the Australia region. And I'm accessing all of this via my laptop in Chicago. So to kind of show you one of the images, first of all, let's go over to Storage Explorer. This is just a quick way to grab an image URL. So we'll grab this top one, copy the URL. I've made these all publicly accessible for this demo, and in my browser I'm going to paste that image, and you can see that came up pretty quick, probably because it's cached in your browser, so that's something to be aware of. And if you go in and create a new and private window, we'll hit it again, and we will see, okay, it takes a little bit of time for that image to come in. It's quite a large image, and it's obviously coming from Australia. So what we can do now is go over to Azure, and let's go and create our CDN. We're going to close this window down, close this one out, back in Azure, and now let's go and create a resource. So click Create a Resource on the top left, go down to Web and Mobile, which is where you will find CDN, select CDN, and it will ask us to create our CDN profile. So I'm going to call mine SL-CDN, choose our subscription, choose our resource group. In my case, I'm going to select SL-CDN, which is a resource group I've already created, and that resource group is in North Central. And now I need to choose my pricing tier. So I can select View Full Pricing Details, and this will bring up the differences between Premium Verizon, Standard Verizon, and Standard Akamai as we described earlier in the module. And my pricing obviously is there as well. And if I go ahead and select, in my case, I'm going to use Standard Akamai for this demo. And finally, I have the option to create a new CDN endpoint now. I'm actually going to skip that for the moment, but let's go ahead and click Create. And in a few minutes, it should create our CDN profile for us, and we will come back to this as soon as that's completed. So as you can see in my resources now, the CDN profile is completed. Let's go ahead and select that. You'll notice a couple of things here. First of all, the pricing tier is listed on the right hand side there, so Standard Akamai as we selected before. And then as you can see on the bottom, I don't have any endpoints currently associated with this profile. So we can go ahead and select Add Endpoint at the top. And now I need to type in some additional details for my endpoint. So first of all, we need to give it a name. So I'm going to call mine SLCDN Images Demo. And you can see there the suffix is .azureedge.net, followed by the origin type. So I'm going to be using a storage account, but you can see there you can use a cloud service from Classic, web apps, or a custom origin, but we're going to use storage account. the origin hostname. So this asks me to select my storage account. So in this case, I'm going to select the SL-CDN demo AUS storage account we used previously. I'm not going to add anything for a path. That allows me to redirect directly to a path in the origin if I want to. And then you can see that it creates an origin host header as well for me, and the protocol port 80 and 443, that's already there. This part on the bottom though is pretty key. I can optimize for general web delivery, which is what I want on this occasion. But if I wanted to, like I said earlier in the course, if we were optimizing for media streaming or video on demand, dynamic site acceleration, those are things that I can select from this menu as well. But let's go ahead and select add. It'll go ahead and create that endpoint for us. It'll take about a minute, and then we'll come back to that once it's completed. Okay, and we can see that status is now running on the bottom there. We have our host name slcdnimagesdemo.azureedge.net. So how do we go about proving this out? If we go into that edge, and in a second it'll pop up, and on the right hand side we have our endpoint hostname and our origin hostname. So let's go ahead and take an image. Let's go down to Storage Explorer, and let's take another one here. Let's take quite a large one. So yeah, 7.8 meg here. We will take this image, copy the URL, go back over to our browser, and let's create a new window and put that in. And this, first of all, we can see how long it's going to take for this image to come across from Australia. Now what we can do is just change the URL on the front of it. So if we go back to Azure, grab this endpoint hostname, let's copy that, go back to our image, and grab it in front and paste over. And now we're basically saying, get me the same image, but get it from the edge, and expand that. Now the first time it does it, it still has to retrieve it from the origin, so we don't get much of an improvement in response time yet. Now I know if I just refresh it now, it's in my browser cache, so I'm going to grab that URL. Let's open a new and private window, paste it in there, refresh, and we can see almost instantaneously the image is available, and that's because it's downloading from a local point of presence in my region. And with that, hopefully you can see the benefits of CDN, how they work, how you configure them, and that concludes this demonstration. I have a favor to ask as you make your way through this course. I'd love your candid feedback on the quality and content delivered.